All right, so we're in our astronomy unit, and we've already talked about the Earth's rotation. So now we're going to move on and talk about the star Polaris. So Polaris is a specific star, and we're going to be on page 17 of your notes of the yellow notebook. And Polaris is also known as the North Star. So when we talk about the North Star, we're talking about Polaris. And there's two things you're going to be able to do. You're going to be able to find where is Polaris, and then also talk about who cares about Polaris. Why is it important? So two things we're going to answer: where it is and who cares. But let's start off by getting our information about the other name. So we have Polaris. This is our notes, page 17. And Polaris is also known as the North Star. To find Polaris is pretty straightforward. All we have to do is look straight above if we're at the North Pole. So if you're at the North Pole, Polaris is going to be directly above your head. And that's why it has its name, Polaris, pole star. So here's the North Pole. You look straight up, and you're going to find Polaris. Well, since it's located directly above the North Pole, that means anyone that lives here in the southern hemisphere is not going to be able to see the North Pole. So for the rest of our conversation about Polaris, whatever we say about Polaris, this is only going to be true if you're in the northern hemisphere. The southern hemisphere, Polaris does not work. You can't see it from there. One of the ways to find Polaris is to take some star trail pictures. We mentioned how if you leave a camera's shutter open for a long time, the stars will appear to have moved through the sky. It's not really the stars moving. What's really happening is the Earth is moving. But the middle star is Polaris, which makes sense because if all the stars appear to be moving because of the Earth's rotation, the star located above the Earth's axis of rotation, Polaris, will not appear to move. Now, it is slightly off, so you can see here in this picture, there's a little bit of a curve for Polaris, but the closest one to the middle. Another way, since you're not living at the North Pole, nor to look straight up, and you're probably not taking a lot of astrophotography nowadays, you can still find Polaris by looking at the Big Dipper. Can you find the Big Dipper in this picture? The Big Dipper is right here. So, whoops, sorry. So there's the Big Dipper. We're going to use the two pointer stars of the Big Dipper. Those are these two stars down here. And what they'll do is they'll point to Polaris. So if you find the Big Dipper, they will point to where Polaris is. We call those stars the pointer stars, and the Polaris is the North Star. Notice how they point to Polaris. Let's get that in our notes. So here's the Big Dipper. If you're ever confused, I'm not sure if I'm looking at the Big Dipper or Little Dipper. You're looking at the Big Dipper. The Little Dipper is really kind of hard to find. So we call these two stars the pointer stars. If we draw a line from those stars, the next star we hit is Polaris. So a couple ways for you to find Polaris. We know it's going to be directly above the North Pole. We can find it using the pointer stars, and we know it's the middle of any star trails that we see. So the star Polaris is located above the North Pole. In this picture here, can you find Polaris? Should be located right there. Notice the pointer stars point to Polaris. All right, great. That's the answer of can you find Polaris? Let's now move on to the who cares Polaris. So we know where it is, but who cares about where it is? This guy cares about where it is. This guy being who? This is Christopher Columbus. So Christopher, when he sailed the ocean blue in 1492 with what three ships? The Nina, the Pinta, and the Santa Maria, and then came on back across the Atlantic Ocean. Well, when you're out in the middle of the water, when you're out in the middle of the Atlantic Ocean, you don't have any land to let you know where you are. There are no landmarks on there. Right? Imagine being out in just the middle of the ocean. And you've got to try and figure out where you are. Well, you can't unless you know about using the stars. You could probably use the moon and the sun as well, But Columbus would definitely use Polaris. And it turns out that since Polaris is directly above your head at the North Pole, that means the North Pole being 90 degrees north equals your latitude. However high Polaris is, equals your latitude. So if you're standing at the North Pole, which is 90 degrees north, Polaris is at an angle of 90 degrees straight above your head. If you go down to the equator, you're standing at 0 degrees, the equator, and Polaris will not be directly above your head. It's going to be straight ahead at 0 degrees, which means anywhere in between, like this person here, they don't look up above their head to see Polaris. They don't look straight ahead to see Polaris. They're going to look up at an angle of 45 degrees, which means if you look up to see Polaris at 45 degrees, you know where you are on the Earth. You're at 45 degrees north latitude. And if we take a look at our notes, notice it says the altitude of Polaris equals the observer's latitude. So we have two things that we're comparing. The altitude of Polaris, meaning how high up in the sky do I look to see Polaris, and a person's latitude. So let's go ahead and draw this in our notes. If you're standing right here at the North Pole and you look straight up to see Polaris, notice that your latitude is 90 degrees north, and the angle you look up to see Polaris is a 90-degree angle. So I've got the altitude of Polaris is 90 degrees. The latitude is 90 degrees north. There's a difference between them, right? Latitudes have a direction. The altitude or angle does not. Be cautious about that. 70 degrees north. If you're standing right here at 70 degrees north, you don't look up above your head to see Polaris. No, Polaris is in that direction. That's the direction you look to see Polaris. You're standing at a latitude of 70 degrees north. We know that latitude is the same as the altitude, means so the angle to see Polaris is a 70-degree angle. This works all throughout the northern hemisphere. This person doesn't look above their head or straight. They look up to see Polaris at an angle of 30 degrees. Therefore, they're standing on what line? 30 degrees north. Great. So if here's somebody out that notice that the sun is setting and Joe is going to look up at the stars, specifically Polaris, to find out where he is out in the ocean. So the altitude of Polaris is going to equal the latitude of the person. Notice the difference between altitude or angle and latitude. Altitude or angle tells us how high up we look.